So in this video, we're going to talk about naming alkenes. And it's this idea of now introducing a carbon-carbon double bond, right? The only kind of addendum to this rule is that now, like always, you're going to always give your alkene, your carbon-carbon double bond, the lowest possible number. But also you got to include that carbon-carbon double bond in the longest continuous carbon chain. And so we can start from here and say, okay, well, this is carbon 1, 2, 3, 4, 5, 6, 7. Well, this would put the the alkene bond at carbon 5. All right, 1, 2, 3, 4, 5. All right, versus coming from here where we'll have 1, 2. It will put the carbon double bond at 2. So listener substituents. Well, this will be the parent, right? So this would be 2. The longest continuous carbon chain is, well, okay, let's see, 1, 2, 3, 4, 5, 6, 7. So now it's not hexane, but 2-heptene, right? 2-heptene, right? That ENE is when we're talking about alkenes. And now we just name our substituents like usual. So we have 1, 2, 3, 4, 5. We have 2-methyl on carbon 5. So the substituents is just 5, 5, dimethyl because we have 2-methyl, right? And then in carbon 6, adjacent to carbon 5, we have 1 more methyl. So that would be 6-methyl. All right, that would be 6-methyl. And because we have 3 methyls here, now we just could combine it and squash everything together. So listener substituents, this would be, given the whole name now, this would be 5, 5, 6. We have 3-methyl, so we're going to simplify that and say this is trimethyl. Right? Then we have a dash, 2-heptene. All right, and this is the older way of naming this molecule. You could also name it by the new IUPAC kind of name, and this is how they do it. It'll be 5,5,6 trimethyl dash hept 2-ene, right? So you want to list the number between the T and the ENE, or right before the ENE, right? So hex-ene would be hex 2-ene right before that ENE. All right, so this would be the new way, this would be the old way. What about this one? Let's see. Okay, well, let's count the longest continuous carbon chain, including the alkene bond. All right, so we have 1, 2, 3, 4, 5, 6, 7. Well, this lists the alkene bond of carbon 1, 2, 3. All right, while this here 1, 2, 3, 4 gives the alkene bond of carbon 4. So obviously we're going to label a substituent from here. So this is for our start counting from here. So this is 1, 2, 3, 4, 5, 6, 7. And let's put a bromine here, just for naming purposes, right? So again, her substituents starting from here, right? This is the longest continuous carbon chain, which will be 7 also, right? So on carbon 2, we have 2 methyl groups. So this is just 2 dimethyl. We just simplify those methyl together. Or we could have just write 2-methyl and then 2-methyl, but I just put everything together in one, right? And then carbon 1, 2, 3. Carbon 3, we hit the alkene bond. So this would be 3-heptene, right? Because the longest continuous carbon chain is 7. Right, I could also start from here and say 1, 2, 3, 4, 5, 6, 7. But I just choose the bottom part because it just looks more simpler. So again, the longest continuous chain is 7 here. So this is heptene. All right, and then on carbon 3 and carbon 4, we have a methyl also. All right, so that's 4-methyl. All right, and in carbon 5, we have a bromine. So that's 5-bromo. And now we've taken care of all our substituents. So squashing everything together, well, B always beats M in the alphabet. So this would be 5-bromo dash 2 2 4 dash trimethyl, because we have 3 of those methyl, trimethyl dash hep dash hep 2 ene. And this again is the newer way of naming things. Again, you could also name it in this fashion, where you could say this is 5 dash bromo dash 2 2 4 dash trimethyl dash, well, it was 3 heptene and not 2 heptene, so I'm sorry about that, dash 3 dash heptene. All right, and I think here, since and I'm sorry about this, but this hyphen wasn't needed because these are still the same. The parent, we just squash it together, so bear with me on this one. The hyphen wasn't needed here, and it also wasn't needed here. So whenever you're doing a new IUPAC name, you just kind of squash the parent and the substituents, the last substituents together, and then you just separate the numbers by dashes. So again, the hyphens weren't needed when we talked about the newer IUPAC names. All right. Now, when we're taking a look at cycloalkenes, right? So what if you're given something like this? So, all right, how would you name this? Well, in cyclic molecules, the carbon that gets number 1 is always the one that contains the double bond. So naming this molecule, I would call this carbon 1, 2, 3, and then 4 goes right around, right? So this is how you would count, right? So this would be, okay, well, on carbon 1 we have the hexene, right? But we cyclohexene because now we're dealing with a cyclic molecule, and on carbon 3 we have a bromo, right? So putting this molecule together, this would be 3 dash bromo dash cyclohexene. Now notice I didn't put 1 cyclohexene. Again, it's kind of trivial because we always give the alkene with we always give the alkene bond number 1. We don't really necessarily need to write 1 cyclohexene. And here's something not to do. Now here's something not to do. Here's how I don't want you to count this molecule. I don't want you to say, okay, this is carbon 1, 2. No, that's wrong. And the reason being is that you have to count across the alkene double bond. So this would be carbon 1, this would be carbon 2. Now we can't go around the ring, obviously, because that will give very high substituent. But again, always count across your double bond. So so it would be here 1, 2, and it's kind of comes into play when, so suppose I was supposed to give you a molecule and say draw the structure of 5 dash chloro dash 6 dash cyclohexene, right? What if I were to tell you to draw this molecule? How would you draw it? Well, again, it doesn't matter where I put my double bond at this point, but we know it always gets priority number 1. So starting from here, because I'm gonna count across my double bond, this would be carbon 1, 2, 3, 4, 5. We have a 5 chloro, so we have a chlorine here, and then we have a 6 methyl. And I'm sorry about that. I should have put the 6 dash methyl here. All right, and this would be the structure of this molecule. All right, so again, and you count across your double bond. How about this one? What if you were given a molecule like this, where now you're introducing 2 double bonds? Now you're introducing 2 double bonds and a substituent like this. What would be the name of this compound? Maybe I should draw it a little bit better. Sorry for my horrible drawing here. Well, again, we know this is a cyclohexene, right? But now, because we have two double bonds, we got to account for those two double bonds. So again, and this is where you could start from your lowest. You could start from your lowest double bond. Not your lowest double bond. Sorry about that, but rather count across your double bond. So you want to include all your double bonds get into your substituent, right? Because you want to give your double bonds the lowest number possible. So you want to include all your double bonds leading up to the substituent. So for that sake, this would be carbon 1, 2, 3, 4, 5, right? Notice I took care of all my carbon to carbon double bond. I didn't say, okay, well, this is 1, 2, 3. First of all, going this way would give your alkenes, your double bond, the highest priority number. But you want to make sure counting, you want to take care of all your carbon carbon double bond. So we'll know this will be 5 dash bromo, because there's only one substituent on this molecule, dash. Well, remember, we got to locate where our in this case now we can't just say, okay, well, it's priority number 1, because now we're dealing with two carbon carbon double bonds. So we got to name where our double bonds are, right? So we have a double bond at carbon 1, and then we have a double bond at carbon 3. So this will be 1, 3 dash cyclo. Now here's where it gets dicey. Now, because you're dealing with two double bonds, this would be cyclohexadiene and not just hexene anymore. And notice this is hexa now, right? So hexadiene, and that di implies that there's two kind of double bond there. And last one I want to look at is this. How about this? So what if you're given a molecule like this and we were asked to name the substituents? Oh, well, name the molecule. Well, again, to all of us, we should know that you got to get our longest continuous carbon chain with an alkene, with the alkene bonds getting the lowest priority groups. So again, we have 1, 2, we have an alkene bond at 2. And then, so 1, 2, 3, 4. We also have an alkene bond at 4. But because we're dealing with two alkenes, it will be diene, right? So it'd be diene. So let's count the longest continuous carbon chain. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this would be 2, 4 octadiene, because again, longest continuous chain is octane. Well, octene, because we're doing alkenes, but because we have two double bonds, we gotta give that diene that implies that there's two double bonds on the longest continuous carbon chain. And then on carbon 5, we have, well, 1, 2, 3, 4, 5, 6. On carbon 6, we have a cyclo we have a cyclopentyl, right? We have a cyclopentyl because now that is a substituent. So remember, we gotta use that that tyl pentyl, include implying that that's a substituent, and that will take care of all our substituents, right? So now putting this molecule together, and bear with me here. I'm leaving out where my cyclopentyl is at. So putting this molecule together on carbon 6, this would be 6 cyclopentyl with 1 else. So 6 cyclopentyl dash 2, 4 octadiene.